All right, so we're going to go through lesson 1.3, limits analytically. Okay, so we're going to start, we've talked about limits, and we're going to look at the limit as x approaches 2 of x squared minus 4 over x minus 2. So essentially what we're trying to figure out here is how we can figure out what limits are without having to look at a graph or a table. Okay, so we have our graph here. So if we're looking at this limit here, when we look at the bottom of this fraction, we can see that we have x minus 2. So what happens here is we're first going to just think about, okay, what's going to happen when I have an x value of 2? So if I were to plug in 2 where my x's are, what am I going to get? So 2 squared is going to be 4, and then 2 minus 2 is going to be 0. So we're going to end up with 0 over 0. So the premise of what we're going to start off with here is what we did in this section right here. So we're going to start off with just substituting in. So let's say instead we had something like this. Now the reason that this part here is 0 over 0, right? We don't want that to happen. There's no point there, and that's because there's actually a hole in the graph there, okay? And so that doesn't actually help us figure out what the limit is there, because what we learned before is that just because we're missing a y value there, we have a hole there, we can still have a limit at that point, okay? I can still see what is happening from each side of the graph and what number am I trending towards there. So let's say that it was 0 instead that we were going to plug in, and we're trying to find the limit as x approaches 0. So if we plug 0 in, 0 squared is 0 minus 4, and then 0 minus 2 is negative 2, so we're going to get 2. And so if we look here, as my graph is trending to 0, okay, so as I'm approaching 0 from the left and from the right, I'm actually going to get a point right there. There's no hole there. There's a point right there. And so the actual value of f of 0 is going to be the same thing as the limit there. Okay? And so this is going to bring us to the first part of this lesson that we're going to cover. And so our first rule, kind of as we're evaluating these limits, is going to be just to substitute. So we're going to do some examples of that where we're just substituting in. And then we'll move on to some other ones, like our situation that we started with where we can't substitute in. It's giving us an undefined value when we do that. Okay, so first thing here, limit as x approaches 2 of x plus 3 over x plus 1. So we always want to just start with substituting in. 2 plus 3 is 5. 2 plus 1 is 3. So 5/3. So this is a case where the limit is the same thing as just f of 2 at that point. Okay, then we'll have limit as x approaches pi over 6 of sine x. So same thing, we're going to plug it in. Sine of pi over 6, and when we do sine of pi over 6, we're going to get 1/2. All right, example 3 here. So if we have the limit as x approaches 2 of x squared minus 4 over x plus 2. And this should actually be as x approaches -2. Okay, so what we see here is when we plug in -2, okay, so when I plug in -2, I'm going to get -2 squared, which is going to be 2. Sorry, 4. -2 squared is going to be 4. 4 minus 4 is going to give us 0. And then when we plug in -2 on the bottom, we're also going to get 0. So when we get 0 over 0, we have a couple of different methods that we can use to try to manipulate this, okay? So that is actually going to be rule number 2. So if you sub in and get 0 over 0, you're going to have to manipulate. All right, so let's try the same example, but we're going to try to manipulate it in a way where it's no longer going to be 0 on the bottom. Now, what I know about this is if I look at the top, I know that x squared minus 4 is a difference of squares, and that's something that I can factor. Every step that we do on these, you need to make sure that you are putting this limit symbol, because you will get points taken off if you're not. And the reason that I'm going to be a stickler on that is because we haven't actually taken the limit yet, okay? So it's very important to know and understand we haven't taken the limit yet, so I can't drop the limit symbols until I actually take the limit. And they're going to take, they'll take points off on the AP exam if you're not paying attention to that, so we need to make sure that we're stressing that all year. So x squared minus 4 is a difference of squares, so that's going to factor to x minus 2, x plus 2. So then I have some canceling that'll happen, and this will go to limit as x approaches -2 of x minus 2. Now I can just plug -2 in and get -4. So what's happening here is I have this, as I'm approaching -2 here, it's making the bottom of my fraction undefined. So there's going to be some kind of a hole in my graph. So I have this hole in my graph at -2, but just because I have a hole doesn't mean I can't have a limit there. And we're going to keep stressing that there's a difference between the y value that we get there, the actual like having a point there, and taking the limit. All right, next example. So limit as x approaches 9 Okay, so we're actually going to look at two different ways that we can do this one. And the first way is just the same thing that we did before, so trying to factor this, okay? And so one thing that we can do is we can look at x minus 9, and we can see that we have this subtraction sign. 9 is a perfect square, and x is something we can take the square root of, so we can actually split this, factor it into the square root of x minus 3 and the square root of x plus 3. Then we'll have some canceling that happens, and I'm left with 1 over the square root of x plus 3. Then I can direct substitute. So I'm going to get 1 over the square root of 9 is 3. 3 plus 3 is 6. So 1/6. Now there's another way that we can do this one. And the other way that we could do that one is to actually rationalize the numerator. So if we take the numerator, and that's the top part, and we rationalize it, so we're going to multiply by the conjugate. Now remember, when we're doing the conjugate means that these two symbols are different, okay? Sometimes people get a little mixed up with conjugates, so we want to make sure that we're changing the correct symbol, and we're understanding kind of what a conjugate's doing. So when I have the conjugate, it's really just the factored out version of a difference of squares problem. So if we think about how, so like we went backwards from here, okay? This is the factored out version of it. So if I'm going from here to this, it's really just the front term squared and then the back term squared and then a subtraction sign in between. So we're going to have the square root of x squared is x, 3 squared is 9, so x minus 9. And then I can see that I have this x minus 9 up top, so I really don't want to multiply the bottom because there's going to be some canceling that I can do. So I can cancel these x minus 9s. And this is where I would have got points taken off because I didn't put my limit symbol, because we have not taken the limit yet. So limit as x approaches 9 of 1 over the square root of x plus 3. Then we can direct substitute. And we'll get the same answer. So kind of two ways you can do that one. Okay, next one is going to be the limit as x approaches 0 Now, make sure that when you're doing these, you're always plugging in that number first. So we always want to substitute first. Then we'll move on to manipulating it if we have to. But if we can just substitute and not have to manipulate anything, that's going to be the easiest thing. Here, if we plug in 0, we're going to get that undefined deal. And so the way that you would deal with something like this, so we have this square root. Okay, so we have this square root right here, and then another term. Okay, so what we're going to have to do with this is we're going to have to multiply by the conjugate on this one. Okay, and so this is where I'm telling you, you really need to be aware of what conjugate means, okay? Because there's some people who would try to change these signs and make these signs the opposite. That's not what we're trying to do. It's the two terms that are separated from each other. That's the sign that we're changing. Always make sure that if I'm multiplying, I multiply by the same thing on the top and bottom to keep it where I'm just multiplying by 1. I'm not actually changing the value of this problem. I'm just kind of changing the look of it so I can do some different things. Now, this is going to be the same scenario where I have kind of this difference of squares problem. So the square root of x plus 25 squared is going to be x plus 25. And then 5 squared is 25, and they'll be separated by a subtraction. And to start with, we'll just not multiply out the bottom just to see if there's any canceling or anything like that we can do before we do that. Then if we simplify the top, we have this plus 25 and a minus 25, so we're going to get x over so my x's are going to cancel, and I'm going to get 1 over the square root of x plus 25 plus 5. Now I'm going to try and plug that 0 in. So that's going to end up being the square root of 25 on the bottom, which is 5. 5 plus 5 is 10. So 1/10. Okay, then we're going to do the limit as x approaches 0 of 2 over x plus 2 minus 1 over x. Okay, so this is a scenario we have kind of a fraction within a fraction. Okay, and so my first thing that I want to do is I want to get rid of these double fractions. So what I can do is I can multiply by this bottom piece so that I can get it to cancel. So I'm going to multiply top and bottom by x plus 2. And just to kind of give you a visual of what happens here, and then you don't have to write this down all the time if you can do this in your head. If you need to write this down, you can. But if you can skip this work and kind of simplify it as you multiply, that's totally fine. So we're going to have some canceling here. We're going to have the limit as x approaches 0 is 2 minus x plus 2. Make sure that that is in parentheses because we're subtracting this whole quantity, not just x. So you want to make sure that you pay attention to that. All right, so 2 minus x, so this is going to become minus x minus 2 when we distribute that. So 2 minus 2, those are going to cancel, and we're going to get negative x over x times x plus 2. Those x's are going to cancel, and we're going to end up with negative 1 over x plus 2. Then we can substitute in and get negative 1/2. All right, example 8. So limit as x approaches 2. Okay, so if we plug 2 in, 2 squared is 4, 4 plus 1 is 5, and then when you plug 2 in on the bottom, you get 0. So this is not 0 over 0. This is a constant over 0. So this is actually going to be rule number 3, but we're not going to learn it today. We're going to learn it later. So that's some constant over 0. So just kind of be aware that's something we're going to learn later. All right, and then last one that we're going to do here. I want to do this one just because I want to review factoring a little bit, just make sure that we can do it. There's going to be quite a bit of factoring you need to be able to factor. You know, I tell my kids every year it's not really the calculus that's just like overwhelming with this class. At times it's, you know, a lot of times it's the algebra, just being able to do the algebra. All right, so when we plug in negative 3 here, we're going to get 0 over 0. So we're going to have to manipulate. I see this x squared plus x minus 6 on top. That makes me think that I could possibly factor that. So the thought process when I'm factoring, and you do not have to think of it this way, this is just how I do it. So when I'm factoring, I'm going to think about this n number, and the thought that I'm going to go through is what are the factors of 6 that subtract to 1. So I'm reading it from right to left. Okay, factors of 6 that subtract to 1. If this was a plus sign right here, then I would say the factors of 6 that add to 1. That really helps you figure out exactly what factors it needs to be. So factors of 6 that subtract to 1 are going to be 3 and 2. And then for the signs, this sign actually is always going to go to the higher of your two factors. So that would make 3. And then if I'm trying to get to 1, so I need to combine 3 and 2 and I need to get 1, the way to do that would be if this was negative. So I have some canceling there. We're going to fill in negative 3 and get negative 6. Oh, I made a mistake here. This should be x minus 2, so negative 3 minus 2, which is negative 5.